Question 15 from the QCAA Specialist External Exam from 2020, and I believe this is on paper 2. Now, you would have noticed with all the videos on the channel, I've started splitting them up into individual videos. That way I can go into a bit more depth on each question, and then the full exam video isn't like an hour or 2 hours long, etc. And if you only struggle with question 15 and other questions, you can go watch those in the playlist. The link to that is in the description below, and the link to the full exam is also in the description below. If you guys want a specialist external exam bundle pack, the link is in the description below, so get your download. But otherwise, let's get straight into question 15, and if you have any questions at all, leave something in the comments, okay? So first of all, this is a calculator exam as well. The position vectors of points P and Q are given here, respectively, and let O be the origin. Determine the angle POQ. So in this situation here, this is your O to P vector, and this is your O to Q vector. So when they're saying the angle POQ, the point P being here, O being there, Q being here, they're talking really just about that angle there, okay? Now that's actually super helpful because we already know what O to P is and O to Q is. So realistically, it's just using this formula here that you would have learned back in year 11 in more of an extension here. So rather than the vector A and B, it'd be the vector O to P and O to Q, etc. to find the angle. So here, what we've got to do is literally just replace it into this formula here to determine this angle here. So here, A dotted with B, instead of that, it'd be O to P dotted with O to Q. Then it'd be equal to the length of O to P times by the length of O to Q. I keep writing Q instead. It's O to Q. Equals times by cos theta. So here we should probably work out what the dot product is first. And here the reason why I can just draw it like this here is because it's a 3D system, so you can always rotate your point of view. So this is still valid here. So here if I go O to P dotted with O, again I keep writing the Q there, O to Q, that's going to be 2, -3, 1 dotted with 2, 2, -4. And when you're dotting vectors, you multiply the x components together, so that will give you 4, plus, and then you multiply the y components together, and then finally you do the same with the z components as well. So here -3 times by 2 gives you -6, so you have 4 plus -6 or -6, and then you have 1 times -4, which is just -4 there, so we get -6 for the dot product. Now we're going to need the length of each of those vectors respectively as well. So here the length of O to P will be it's just using Pythagoras' theorem in 3D, so it's going to be each of the components all squared and then square rooted. So here you chuck that into your calculator, because remember this is a calculator exam, don't waste your time doing all this easy stuff here if you've got access to a calculator. So what would this give us here? So this gives us the square root of 14, and then if we're doing the length of O to Q, square root 2 squared plus 2 squared plus -4 all squared as well. Now we'll just move this out the way and calculate this other one as well. So this gives us, it actually simplifies the third and turns into 2√6. So now we know everything for this formula here. So we know the dot product here was equal to -6. We know the length of OP was the square root of 14. And we know the length of OQ was 2√6. So to get the cos theta by itself, you'll divide both sides by this. So you have -6 over square root of 14 times by 2√6. That is your cosine as well. So if they ever ask you a cosine, this would be it, because this is the ratio of your adjacent over your hypotenuse as well. Now all we've got to do is get the theta by itself. So you're going to cos inverse both sides to cancel out the cos here, and then we chuck this guy into our calculator. Now make sure you are in degrees here. I'm assuming they want it in degrees. If not, if you're in radians, this will give you some sort of decimal number perhaps. So here we get 109.1 degrees roughly. Okay. Here they haven't said what decimal places, so here we're just going to put 109.1 degrees. Okay. All right. So in this situation here, I'd say this is a pretty easy question. There's a lot of basic stuff to calculate. However, none of this stuff should be new. This would be, I'd say, a year 11 question definitely as well. Now, just in case we need any of that stuff, I'm just going to rub out this bit here. Now let's get on to the second part of this question. So here, determine, so the points O, P, and Q form a triangle. So here if I just extend that, we've got a triangle. Determine the area of the triangle. Now, there's two ways to do it. There's a very fast way and there's a very slow way as well. Because you have a triangle here, if we already know that length and that length and that angle there, we could just use this formula, a half BC sine A, from methods if we really wanted to. So this would give us a half times by the length of one of the sides, which could be either one of these guys here, so root 14. Then times by the other side length, which would be 2 root 6, and then sine of the angle, which is 109, which we just calculated there. So this is one way to do it, and if I was in the exam, I would do it this way here, because it's a lot quicker than the other way, but I will show you the alternative as well for this video here. So here we were to calculate this. Now this is assuming the angle was correct as well, and I haven't rounded super far. So it won't give an exact answer, but it will give you a range because I've rounded the angle to a decimal place or two. So this gives us, if I can calculate it, about 8.66 recurring. Okay. So in this situation, that's the quick way to do it. The other way you could do it, and the one they might expect you to do in specialists, but we'll keep this area somewhere because we'll compare it a bit later, is to find the cross product. So if you cross two vectors, it will produce a vector perpendicular to both of them. So in this situation here, if I were to cross O to P and O to Q, it would produce a vector like this or like that that's perpendicular. The length of that though is actually equal to the area if this was a parallelogram. So what we can do instead is find the area of that and divide it in two, which would give you the area of the triangle. So the area of this triangle would be a half the length of O to P crossed with O to Q, which is what they may expect in specialists as well. Now crossing vectors is pretty easy. Oh, no, never mind. It's not super easy, but I think it's easy. Okay. So what we don't need any of this information though to help us with our answer. So what I'm going to do is I'm going to rub it out and let's set this guy up. So first of all, we need to cross the vectors, okay? Then we'll worry about the length. So here when we're going O to P, now you don't have to go O to P cross O to Q, you could do it the other way because it will just give you the vector in the opposite direction. So when you're crossing two vectors, you set it up in a 3x3 matrix. You have I, J, and K on the top to represent the components. In the first row here, you have the first vector listed. So here, because it's O to P, I'm going to put the 2, the -3, and the 1 here. So 2, -3, and 1. Then for the bottom bit, I'm going to have the 2, 2, -4. 2, 2, -4. Now, when you're crossing this, you're finding the determinant of a 3x3, which means it will break down into 3 2x2s. And it has to go plus, minus, plus. Now, the first vector, the first matrix here is going to be for cross this, cross that. It'll be -3, 1, 2, -4. So -3, 1, 2, -4. And here, this bit here goes there. So that's the I component. Then it has to go minus, and then the next matrix here would be 2, 1, 2, 4, -4, sorry. So 2, 1, 2, -4, and that's the J component. And then for the last one, move that line across, you're going to have plus 2, -3, 2, 2, K. Now you can already see this way is a little bit longer than the other ones. Now we've got to find the determinant of each of these here to determine our vector. So if you remember, if you have a vector a matrix A, B, C, D, the determinant of that with those those vertical lines there would be A times D minus B times C. So we're going to do this with each of these guys here. So you're going to have negative 3 times negative 4, which gives you positive 12, minus 2 times 1, which is 2. So that's your I component. Then here you're going to have negative 4 times by 2, which is negative 8, minus 2 times 1, which is minus 2, and don't forget to times that by a negative as well at the front. And then here you're going to have 2 times 2, which is 4, minus 2 times negative 3, which is negative 6, but since you're subtracting, it's going to be positive 6. So here we have 10i, then here you're going to have positive 10j, and then here you're going to have 10k as well. So here we get 10, 10, 10 pretty much. Alright, now what we do next is that is our normal vector, okay? That is the vector when you've crossed them together. Now again, you'd have to check a calculator as well. And I'm just going to double check those very quickly. So that's, yep. I do it all in one take, so if I make a mistake, it will pop out straight away. Yep, okay, we're all good. Looks like we're all good. Now we just got to find the length of this guy here. So the length of a vector, again, is that Pythagoras theorem thing we did there, where we square each of the components and then put it under a square root. So we'll do this guy here. So here, chuck that into your calculator now. Now, realistically, if this was an exam, I wouldn't do this method. However, it's always good to know the other one as well. Now, this will give us 10 root 3. Now, all we've got to do is divide it by 2 as well. So here, divide it by 2, because again, that's going to give you the area of the triangle. So times this by a half. So 10 root 3 over 2. And if you put that as a decimal, that's roughly 8.66 there. Roughly like that. Which actually matches the other one we had there as well. Okay. Which method's better? First one's better. Second one goes in a bit more depth as well. And if you need the area of a parallelogram, it can help that as well. Okay. But again, if you had any questions about question 15, leave something in the comments below. If you need a specialist external exam bundle pack, our link is in the description below. And if you want the link to the full exam, the playlist is in the description as well. Alright, and I'll see you in the next video.